Okay, this is an example of a hand boiler. Basically, it's a thin piece of glass that has two bulbs, one at each end. Inside there's a colored liquid, and the liquid would probably fill about half of one of the bulbs. I'm going to place my hand on one of the bulbs, and it appears that I'm causing the liquid inside to boil. And then when I place my hand on this bulb, the liquid moves over to the other side and it again appears to boil. Am I generating enough heat to boil the liquid that's inside of this container? Use what you know about the kinetic theory to help explain what you think is going on here. Could it be water, or could it be some other liquid? Think about what normal body temperature is, 98.6 degrees Fahrenheit. Is that enough energy to boil a liquid? If you think that there's another explanation, specifically related to molecular movement, pressure, then use that to explain what's going on. Okay, this demonstration was called air freshener. Basically, in the classroom, we took the air freshener can, went to one corner of the room, and sprayed a copious amount of the air freshener in that area. We asked students to be honest and raise their hands when they were able to smell the air freshener. What we noticed was that after we sprayed the air freshener, students who were closest to where we sprayed started to smell the odor first, and then it progressed throughout the room all the way to the front. So people who were all the way at the front of the room near the door were the last people to eventually smell the air freshener. Can you explain why is it we were able to spray the air freshener in one corner of the room and have people on the opposite side of the room smell it within about a minute? Is this related to diffusion? Can you explain, using the kinetic theory, how this was able to happen? If the room was 10 degrees cooler or 10 degrees warmer, how might that affect the rate at which the air freshener would spread throughout the room? Okay, this demo lab is called the radiometer. And basically what we have is an object that looks like a light bulb, but it's really not. Inside there's a little bit of air. There's a vertical axis on which there are 4 panels. On one side of each panel it's colored in black, and on the other side it's colored in white. What we're going to do is shine a light directly on or directly near the structure or the radiometer, and let's observe what happens. What you notice is that when the light is turned on, the panels start to spin. It doesn't matter where I place the light, the panels always spin in the same direction. The white side tends to be leading and the black side is pushing. Think about what you learned from light and optics last year in 7th grade. You learned that darker colors absorb light rays, whereas white colors or light colors, the color white, reflects light rays. So if that's the case, might the darker side be warmer than the white side? And if there are air molecules that are next to the darker side, are they going to gain more energy and push off or push the dark side more than those air molecules that are next to the white side? Okay, this demonstration is called hot and cold flasks. Basically what we have are 2 flasks. This one is filled with hot water that's around 200 or 205 degrees or so. This one is filled with cold water. I'm going to take a little bit of food coloring and put it into the hot water flask. Notice the rate at which the dye spreads throughout the water. To this point, you've learned that diffusion occurs at a higher rate when the temperature is high, and as you can see, the color is spreading quite rapidly. What we're going to try to do is take the cold water flask and invert it so that the lips are touching and it's on top of the hot water flask. Think about what the molecules of water, and think about how they're behaving inside of the hot water flask right now, and how that might be different from how they're behaving inside of the cold water flask. All right, I have a glass plate that I'm going to put on top of the cold water, and I'm just trying to fill it so that there are no air bubbles inside. Okay, so carefully I'm going to take the cold water flask and invert it and place it on top of the hot water. All right, I'm going to remove the glass plate and let's observe what happens. All right, we notice that the hot water appears to be defying gravity and is moving up, rushing up into the cold water flask. The cold water is moving down into the hot water flask. In the middle, where the necks are, where the lips of the flasks meet, we see sort of a shimmering effect going on there, and there's actually has a little cyclic motion. This is due to the uneven heating of water. The warm water, as it's rushing up, it's heating the cold water as it's falling down, and it's creating somewhat of a convection current in the neck of the flask. How does the densities of these two affect how they're behaving right now? The hot water, because the molecules are more active, they're spread apart, they have more energy, they are less dense than the cold water, so they're moving up. The cold water has less energy, the molecules are more compact, so they're more dense than the warm water, so they're sinking. If we leave this for another couple of minutes, we probably notice that the convection would stop in the center and the flasks would be pretty uniform in color.